Assalamualaikum. My name is Hassan Adil. In this video, we talk about what is computer, what is computer languages and algorithm, flowchart, etc. What is computer? A computer is an electronic device that processes data and performs tasks. For instance, they have become integral in modern life, facilitating everything from simple calculations to complex simulation. Understanding the various types of computers, their hardware, software components, and the language used to program them is essential for students and professionals in computer science and technology. Here are some main components of computer, like CPU, Central Processing Unit. CPU is the brain of computer responsible for executing instructions. RAM, a temporary storage that holds data and instructions currently in use. Motherboard, the main circuit board that connects all components of computer. ESU, power supply unit, converts electrical power for computer. Now we talk about types of computer. Here are the following types of computer. Personal computer, designed for individual use, suitable for tasks like word processing and gaming. Laptops, portable computer that combines the features of a desktop PC with mobility. Mainframes, large powerful system used primarily by organizations for bulk data processing. Servers, powerful machines that provide resources and services to other computers over a network. Supercomputers, extremely fast computer used for complex simulations and calculations in scientific research. Now we talk about input and output devices. Input, what is input? Input hardware used for enter data into a computer such as keyboards, mouse, and scanners. Output hardware that convey information from a computer to the user such as monitors and printers. Memory. What is memory? Memory are of two types, volatile memory and non-volatile memory. Volatile memory are those which are temporary storage that loses data when power is off. Example RAM. And non-volatile memory is permanent storage that retains data without power off. Example hard drives, SSDs, etc. Trends in computing. Artificial intelligence, quantum computing, cloud computing, 5G network. These all are the trends of computers. Artificial intelligence, machines making human intelligence. In quantum computing, future technology with much faster processing. 5G network, faster wireless communications. These are computer languages. High level language, low level language. In high level language, easier for human to read and write. Example Python, Java. Low level language, closer to machine code, harder for humans. Example assembly language.
Now we talk about problem analysis in programming. Here are a few steps for problem analysis programming. First, understanding the problem. Find the core issue before finding the solution. Define requirements. Identify what is needed to solve the problem. Identify concentrates. Recognizing limitations that affect the solution. We should take these general steps in problem solving. Define the problem, analyze the requirements, develop a solution strategy, implementations problem. Then last, test the evaluation of solution. What is algorithm? Step-by-step procedure of solving a problem. Provides clear instructions to achieve a desired outcome. Essential for programming and problem solving. What is flowchart? Visual representation of algorithm and process. In flowchart, there are different types of symbols used to represent the various actions or steps. Flowchart is also used for understanding the flow. They help in understanding the flow of control in a program. Here are the different symbols used in flowcharts to represent the flow of program. An oval represents starts or end point. A line is a connector that shows relationship between the representative shapes. parallelogram represents input or output. A rectangle represents a process. A diamond indicates a discussion.
Now we talk about the CPU, how it works. First control unit, then the information goes to instruction register, and then program counter. These are done by input devices. Then the output becomes arithmetic logic units, ALU. Then the main memory, the information goes to secondary memory, and the cycle moves. Computer only understand digital signals, zeros and ones. Language consisting of binary commands directly understood by CPU. Binary digits are known as zeros and ones. Binary code, sequence of zeros and ones, byte. Eight bits are equal to 1 byte. Byte is equal to 8 bits. Kilobyte symbol is KB is equal to 2 raised 10 raised power bytes or 1024 bytes. Megabytes symbol is MB and it's equal to byte is 1024 KB or 2 raised to power 10 KB. Gigabyte GB 1024 MB or 10 raised to 2 raised to power 10 MB or 230 bytes. Terabyte symbol is TB. In bytes 1024 GB or 2 raised to power 40 bytes. Petabyte PB 1024 TB or in bytes
2 10 raised to 2 power of 50 bytes exabyte EB 1024 PB or equal to 2 raised to power 60 bytes zettabyte ZB 1024 EB or equal to 2 raised to power 70 bytes. This is the whole table of bytes to zettabytes. Now we discuss assembly language in detail. Assembly language is closer to human as compared to machine language. Instructions and mnemonics, English-like word. Assembler, tool that converts assembly code into machine code. Example, load. In binary, we see that 100100 and you see the table. Assembly language code to calculate the area of rectangle. Area of rectangle is equal to length multiplied width is equal to load is high level language that are easily understood by humans. High level language are C, C++, Python, Static, and Java. Compiler tool translates source codes into object code. The equation area length multiplied width can be written in C++ as area is equal to length squared width. C++ language is easy to understand. Algorithm and flowcharts. A typical programming task can be divided into two phases: problem solving phase or implementation phase. Problem solving phase produces an ordered sequence of steps that describe solution of problem. This sequence of steps is called an algorithm. Implementation phase. In implementation, the program in some programming language. Steps in problem solving. First, produce a general algorithm. One can use pseudocode. Define the algorithm successfully. You get step-by-step detailed algorithm that is easy, that is very close to a computer language. Pseudocode. What is pseudocode? Pseudocode is an artificial and informal language that helps programmers develop algorithms. Pseudocode is very similar to everyday English. It is like blueprints to your program. Pseudocode is a way to plan out your code before you actually write it. You write down the logic of your program in plain, easy to understand language without worrying about the exact syntax of any particular program language. Great way to ensure you have the logic figured out before diving into the actual code. Here is an example. Write an algorithm to determine a student's grade and indicate whether it is passing or failing. The final grade is calculated as the average of 4 marks. Let's solve it. Now first we make pseudocode. Like we just input a set of 4 marks. Then we say calculate the average and dividing by 4. If average is below 50, then print fail. If average is above 50, then print pass. We use if in this program. In algorithm, we write it in steps. So our first step is input M1, M2, M3 and 4. M1 will be a student 1, student 2, student 3, student 4. Step 2 grade is equal to M1 plus M2 plus M3 M4. We all these grades of student divide by 4. So if grade is less than 50, then print fail. Else print pass. This is a simple program. Flowchart. Dictionary meaning: magnetic representation of sequence of operations as in a manufacturing process or computer program. We see it in technical way a graphical representation of sequence of operation in an information system or program. Information system charts show how data flow from source documents to the computer to final distribution to users. Program flowcharts show the sequence of instructions in a single program or routine. Different symbols are used to draw each type of flowchart, like we previously talked about in it. We have an example, like we make it this example in flowchart, which we previously make in algorithm and pseudocode. We use the oval for start, parallelogram for the information, and rectangular for the sums and addition. For discussion, we use the diamond, and we see this. We have another example in which what is saying that write an algorithm and draw a flowchart to convert the length in feet to centimeter, like percent feet. Okay. Here we also have pseudocode for it. Input the length in feet and multiply by feet. Calculate the length in centimeter by multiplying L multiplied by T with 30. Print length in centimeter LCM. We multiply by 30 because
In 1 feet there is 30 centimeter. That's why we multiply by this with 30.